We are a little bit beyond our time for a break. We got a late start here, actually, but we'll take, let's say, 5 minutes for questions. Again, I hope we get some good questions from the audience. We have someone with a microphone for these folks. Right up here up front, please. Meanwhile, I want to thank all of our presenters, and I want to present each of you a gift from the CTBUH as a token of appreciation.
Hello.
I'm going to ask that you identify yourself and your affiliation for all of the benefit of everybody here. Thank you.
Yes, thank you for the chance of asking a question. My name is Nagaraj. I'm a practicing engineer from Germany, and I have a question regarding the egress system with elevators. You didn't address the issues of pressurizing the elevator shaft, and in case of the lobby, if you have to pressurize it, and also provide some airflow, because that's a very strong issue as of now in Germany, because the new high-rise building regulations have been just issued, and we would have a lot of difficulties in getting the permits which Simon just presented for 35-story building without pressurizing the staircase.
We, in some of the single-stair buildings we look at, we are looking at pressurization, but generally, actually, we're using systems which achieve similar effects but aren't pressurization. For example, on the Beetham Tower, like I say, that uses a mechanically assisted natural ventilation solution to the lobby, which is a shaft with a pressurizing duct that feeds air in. We don't use the word pressurization because they're engineered solutions. If you say pressurization, it means you're designing to a specific code, which is there for specific reasons. When we're engineering these solutions, we tend not to use the word pressurization. So we have a number of different options which achieve the similar level of protection as pressurization. One of the problems we have, particularly in the UK with our own pressurization code, is that the amount of design information and certainty you need about the building when you start building it means that when you come to test the building, often pressurization systems are either massively over-designed and you get lots of other problems to do with doors opening, or they don't work at all, they fail completely. I've been to building tests where the pressure was supposed to achieve 50 pascals and it achieved 2.5 in a test, for example. So what we've tended to do is look at these alternative methods, and the whole point about these ventilation systems is that they're very robust in terms of the building design process, that we can look at achieving very high air exchange rates within lobby spaces and such like. Because we don't tend to take off lobbies if we put pressurization into buildings, whereas under a lot of the codes around the world, you pressurize, you don't need to put lobbies on, etc. So we tend to protect the lobby space and try to use that rather than trying to pressurize the staircase in a lot of cases. So we can use pressurization, but we found as a design solution, perhaps it's to do with British construction techniques, I don't know, but it tends to work better if we use alternative solutions. It's just a bit more robust, because if we need to put a bit more air into these mechanically assisted systems, it's a relatively simple matter of making the fans slightly bigger. With a pressurization system, if it's not working, if you're getting big losses through the system, putting a bigger fan on isn't necessarily going to solve it, because you end up with diminishing returns.
Okay, thank you. NFPA, do you have any scientific information regarding the demands of the new high-rise regulations in Europe, which at least initiated from Germany? They demand 0.75 meters per second of airflow during the firefighting, which I'm vainly trying to get the reason behind it, because I don't understand the purpose of this airflow out of the lobby of a fire elevator.
Well, I presume that's there to protect the firefighting shaft, so that most systems for firefighting shaft protection is there to protect the line of retreat for firefighters. So you have the elevators to get them in quickly, but if they need to get out, they need to be able to get down a staircase and get away. It also means that the staircase hopefully is also available for people coming down from above. And people, one of the biggest problems you have is if people are inside a shaft, and people, when they start firefighting operations, then chances are the firefighters are wearing a lot of protective kit. You get a serious contamination of a staircase, and you can kill people trying to come down that staircase, even if they're sort of waiting there for firefighters to get out of the way. It's a very, very serious problem. So most of the systems are designed to stop the smoke getting into the staircase in the first place, and that's what that flow rate would refer to.
A couple more questions.
Tony Marshalsea, I'm from Omrani Associates in Saudi Arabia. Talking about times for egress, you put on here 90 minutes for evacuation using stairs. 7 years ago, when I was a lot thinner and a lot fitter, I tested how long it would take me to get from the top of Kingdom Tower, Riyadh, down to the bottom. That's 300 meters. It took me 20 minutes as fast as I could go, and at the end of it, my legs were just giving way. So I can understand the requirement for refuge floors, and I can understand that in a building 3 times as high as Kingdom Centre, that's going to take at least 1.5 hours for a reasonably fit person to get from top to bottom using stairs. So 3 hours fire safety might just make it. The other thing is, there's a couple of other things. One...
Do you have a question for our presenters?
Yeah, Mr. J. Mr. Lay, have you tried getting your scissor stairs approved in USA? Because most USKs won't allow them. The other point I'd like to make is, here in the Middle East, we can't use natural ventilation for stairs because we have negative stack effects, so we just rely on pressurization. Thank you.
No, I agree. In the UAE, you tend to follow sort of an NFPA-based pressurization code, which is a lot more reasonable than the British code. You also have the situation, yes, you're right, single staircases are uniquely, well, not quite uniquely British, but it's predominantly British, and Australasia, I think, also allows it. There's a lot of things that come together relating to firefighting tactics, defend in place. The main reason we do it in the UK is to avoid false alarms and people being evacuated from buildings unnecessarily, and the cry wolf mentality. That's where it sort of came from, and it does work extremely well. People in residential buildings don't tend to die in the staircases, they tend to die in their apartment. The question about the 90 minutes, I totally agree. It's very, very difficult to hit those targets in a very tall building without using elevator escape, and I think that's what's going to push us towards seeing a lot more elevator egress, because I think, as I say, it's, when you look at the table, we start to get to this sort of essential part of the building component, because, yeah, you're right, most reasonably fit people, even a fat so-and-so like myself, can actually get down a reasonably high-rise building a lot quicker when the stair's completely empty than a lot of the calculations would tell us. And the figures we tend to use are quite onerous calculation figures, but that doesn't really help you because there's no real allowance for the deterioration in your movement speed as you walk down very, very big distances. There's a lot of research into sort of tunnels and such, like people walking out of tunnels and the deterioration under those conditions, but there's not a huge amount of data out there unless you guys know much about the deterioration of the performance of people walking down long staircases.
We'll take one more question here before I get fired as a chair for the next time. Mr. Vanny, right up here.
Aaron Vanny with Ralph Jensen Associates. 2 quick questions. Thanks for all you presenting. But Dan, you listed a number of examples in your presentations of fires that have occurred and have spread throughout the building. How many of those buildings were sprinkler protected or had an operating sprinkler system? And then also, early in the presentation, you had mentioned a couple of alternatives. A lot of money is spent on the facade of these buildings. Earlier today in this conference, what were some of those alternatives that you had mentioned?
Yeah, on your first question, how many of those buildings were sprinklered, is really only the one in Venezuela that was fully sprinklered. And I guess the point I was trying to make here is that we do know that sprinklers in high-rise buildings are quite reliable and quite dependable. But my use of the other examples was try to illustrate that if and when the day comes, and it would be a rare event, I think, that in a fully sprinkled building you might have a sprinkler system shut off or a riser shut off, maybe for maintenance. At the same time, you have an ignition there that we could see transition into a very large catastrophic event. So as far as the alternatives go, what I think it is we have to really take a hard look at how we design our sprinkler systems for high-rise buildings. We want to definitely make sure that the sprinkler systems have high degree of reliability. Perhaps gravity systems or all gravity systems are a thing to consider. Maybe dual riser feeds. I know in the city of Boston, they require dual riser feeds to the sprinkler system, so somebody couldn't necessarily shut off the riser on one side and lose your supply to the floor. So I think the responsive thing here is that we really have to take a close look at how we design our sprinkler systems. I mean, there could be some other alternatives. I showed some of the data where they used lines of sprinklers at the facade. Perhaps that could be piped independently from the standard area protection sprinklers in the building to offer redundancy at the curtain wall line, things of that nature. But even you can see the compartmentation features in these buildings can have a mitigating influence too on these events.
I want to thank our presenters. I want to thank our audience. Sorry we ran a little bit late. If you have any additional questions of our presenters, I ask that you catch them out in the hall during what remains of our break this afternoon. Thank you very much.